The last thing I'm going to talk about today is user-defined functions. I hope I've made it clear at this point that functions in R are objects, just like any other objects, like numeric vectors or data frames or lists. And you can define new functions yourself using the function. um, and here is an example of that. This is a very simple example. This is not something you would ever want to actually do. But here I'm going to create a new object called increment. I am assigning it the value that is the result of this function call. The function is called function in this case because that is the name of the function that creates a new function. And I'm supplying arguments, which in this case are my way of telling R what arguments I want it to expect for this new function called increment that I'm creating right now. The first argument is called x and has no default value. And the second argument is called by and has the default value of 1. And then in the curly brackets, I have just the lines of code that I want to run every time this function increment is called. And I'm running one line of code here, which is return x plus by. And so the result of this will be to take the value x, whatever it is, and increment it by some amount. By default, 1. So if x is 4, I should get 5. If x is 5, I should get 6. But if someone supplies an argument for by, that's different from 1, then it will increment the first argument by a larger amount. So again, this is simpler than anything you would probably want to do in a function in real life, but it serves to illustrate a point. So here I've defined a new function called increment, and if I increment 1, I get 2, because 1 plus 1 is 2. If I specify my second argument to be something other than the default, such as 4, increment 1 by 4, then I get 5. And if I don't specify by equals 4, but just make the second argument 4, it still works just fine because R keeps track of the order of the arguments and will apply the values in order to the appropriate arguments as long as you've supplied them in the proper order. But sometimes it can be less ambiguous if you supply the names of certain arguments, like in this version. To repeat that, if you supply the names of all the arguments, you can list them in any order. It doesn't matter. The names are the primary way of determining which argument is which. But if you don't supply names for the arguments, then the order has to match. Let's take a look at another example of a user-defined function. This one has a real purpose, unlike the increment function that I used as my first example. This is a short function that I wrote to perform min-max normalization using either the empirical minimum and maximum or any other specified target minimum and maximum. And it's still a very short function, which is why I'm using it as my example here. So this is the function definition right here. All I did is create a name, min-max, and I'm assigning it a value, which is the result of this function specification. And the function is going to take these arguments. X is the first argument, and then there's 4 others: old min, old max, new min, and new max. By default, new min and new max are 0 and 1, and that's because I want the default behavior of this function to take a variable x and transform it so that it has minimum value 0 and the maximum value 1. And I want R to figure out what the old minimum and old maximum were. But the function is flexible enough to allow the user to specify what the old minimum and old maximum should be taken to be, and what the new target minimum and maximum should be. And then within the curly brackets that start here and end here, I have the 4 lines of code that are the function itself. Before I walk through those lines of code, I want to go back to this example before, because I didn't mention what was the deal with return. If you've programmed before, most languages, when you define a function, it's going to return a value. And often the value that the function returns is specified using a function called return. So that's what I've done here. This return just means this, whatever is the argument to return is what I want to be the output of the function that I'm creating called increment. In R, the last line of the function will be the return value if you don't call return within the function on purpose. But I think that's ambiguous. I prefer not to do that, so I always use return to make it very clear what value I am intending to return. Okay, so down here in my min-max function, the first thing it does is it determines if the old min argument has a length equal to 0. The value null has 0 length. So this is a handy way to determine if old min has been left at its default or changed to something else. And if it has been left as its default, which has length 0, then this line of code is run, which assigns a new value to old min, which is the minimum of the variable x after removing missing values. So this is the empirical minimum of x in most cases, unless the user specifies some other minimum. The same thing happens for old max. If it has been left to its default with 0 length, then it's overwritten with the empirical maximum after removing missing values. Then I calculate something called unit min max, which is this x minus old min divided by old max minus old min. This is a version of the variable x that has been shrunk down so that fits in the space between 0 and 1. And then the value I'm going to return is that version of the variable x, that vector, multiplied this vector, right, unit min max from over here, but multiplied by the difference between the new max and the new min plus the new min. So if those are left at their defaults, then this part does nothing. But this will allow whatever the user specified as the target minimum and maximum to get used. If you don't understand all of that, try thinking it through yourself and then asking me questions as needed. But after I run this, min-max exists as a function, and I can do things with it. Let's say I create this fake variable rating, which has these values, 3.5, 4.1, 3.9, 6.0, and 5.4. Then if I run min-max on it with default values, then it will make 0 the minimum and 1 the maximum, and the other things spaced out in between them as they were spaced out in between the minimum and maximum originally. I can specify the old minimum and the old maximum to be something else. So this would be useful if, for example, I wanted to treat these values of rating as being ratings on a 1 to 7 scale, where 1 is the true minimum and 7 is the true maximum. And this is just a subset of possible values, that none of which happens to be at the true minimum or the true maximum. Here, those values are constrained so that they fall within the range from 0 to 1, where 0 is the true min and 1 is the true max. I could also change it so that, for example, I wanted the new minimum and new maximum to be 0 and 100 instead of 0 and 1. And I could do all of those at the same time, so that now these are like percentages of the scale range represented by these original values. This is just to illustrate how I can call a function and use some of the defaults, but not all of them, or even assign the values of all of the arguments to the function in the most complex case.